Remember, the AP test is 30% about pollution, so we want to really focus on these chapters. So air pollution defined as introduction of chemicals or anything into the atmosphere that's going to harm animals, plants, or buildings. It can destroy buildings, like acid rain can destroy buildings, or it can alter an ecosystem. So that's the definition of an air pollutant. These are major air pollutants that we have, that we worry about around the world and in the United States. These come from burning fossil fuels, especially coal. Nitrogen oxides come from your car exhaust and a lot of other burning situations. And carbon monoxide, carbon dioxide come from burning as well. Particulates, hey, burning again, and also from things like dust, like from transportation. There's lots of dust that comes from buses and cars driving on roadways. So particulates are another air pollutant. Volatile organic compounds come from from manufacturing. So making paints or solvents and things like that, you'll get volatiles coming off. A lot of different industries make volatile organic compounds. They're called VOCs for short. Ozone comes from vehicle exhaust in the mainly. So that's where you get ozone. Lead and mercury come from burning fossil fuels. So here's all the pollutants, and there's a lot to look at on this chart. And it tells you exactly where everything comes from. We're talking here about where things come from humans, so that's called anthropogenic. Remember, anthropogenic just means human-derived things. Anthrop comes from the word man, so all these things can come from man. So, like I said, sulfur dioxide comes from burning fuels, and it's going to affect our respiration, because it turns into, when it combines with water, it turns into sulfuric acid, so it's not a good thing for us to breathe. Same with nitrogen oxides. We're going to get nitric acid from that. And it's also going to hurt vegetation when it falls down in acid rain. So these two things make acid rain. Carbon monoxide is not good for us to breathe because it bonds with our hemoglobin, and if we get too much of it, we'll die. It actually bonds better than oxygen, so it will interfere with oxygen, so it can kill you, and also it makes it so you're not getting enough oxygen in your system, so it's not good in that way. Particulate matter, especially really small stuff, is called PM10. It's smaller than 10 microns. Is really bad because it goes into the bottom of your lungs. I'm looking for the picture on page 413. You should look at that picture. It tells you the different sizes. So like a hair is 100 microns, and we're talking about stuff that's 10 microns, which is really tiny. And things that are even less than that, 2.5. These things are things that can go into your lungs and they go way deep into your lungs, and you can't cough them out, so they're not good for you. And they stay in there forever. You can't get rid of them. Your body can't get rid of them. So we always worry about particulates that are really small, 2.5. PM 2.5 are the ones we really care about the most. And these come from combustion, and also agriculture, road construction, other things where you have a lot of dust coming up in the air. Lead comes from gasoline additives. In the old days, we added lead so our cars wouldn't knock and they would run more smoothly. So in the United States, we don't use lead, but in other countries, in developing countries, they still use lead. And they also put lead in paint, so these things are bad for us. Lead and mercury are neurotoxins. They're bad for your nervous system. So for little kids, it's going to keep them from learning. For older people, it's going to give headaches and problems with all your nerves. Ozone is there's two kinds of pollutants. There's primary and there's secondary pollutants. Secondary pollutants happen when different chemicals are in the air and then they get exposed to sunlight, water, oxygen, things like that, and they do a chemical reaction. So ozone is a secondary pollutant. Ozone is great way high up in the atmosphere, but in the stratosphere, but down at ground level, it's really bad for us to breathe. It's hard for us to breathe. It reduces our lung function. So ozone is bad at where we live in the troposphere, but it's really good in the stratosphere. So you have to remember that on AP tests they might try to trick you. So remember, at our level, ozone's bad. Way high up, it's really good. And there's other volatile organic, other pollutants like VOCs. We talked about those. Mercury comes from mining as well as burning different fuels, and carbon dioxide comes from burning. This is the picture I was talking to you about. These are the smallest PM 2.5s are the ones we worry about the most because they can go into your lungs and not come out. These all come from, there's natural things, volcanoes, wood fires, forest fires make particulates. So these are natural things, and then there's anthropogenic things, which are road dust, vehicle exhaust, fossil or burning fuel power plants. So primary pollutants come from a particular thing like a smokestack or a car or things like that. Those are primary pollutants. And secondary ones are those primary get exposed to something like sunlight, water, oxygen, and then they change into something else. So ozone is something that happens from combustion of cars at street level, and then it changes because of sunlight into ozone. We can deal with some of this pollution by different processes in different manufacturing plants and power plants. One of these is called a scrubber, and what happens here is water is misted through you have the particular dirty air coming up through this stack, and then they drip water through it, and that's called scrubber water. And that water will pick up any particulates, and then it'll go down here and make a big pile of sludge that they get rid of later. So that's called a scrubber, and it uses water to clear off the dirty air. There's natural sources of air pollution. There's volcanoes, lightning. Lightning makes ozone. Forest fires make particulates, carbon dioxide, carbon monoxide, and plants actually give off volatile organic compounds. So when you're in a forest and you smell that beautiful pine tree smell, those are terpenes. Terpenes are an air pollutant, so they can make smog, and they can be bad. So that's why the Smoky Mountains back east are called Smoky Mountains, because all those beautiful pine trees are making terpenes, and they react with the sun and they make this smog right here. So plants can actually make air pollution. So like I said, there's anthropogenic sources, and these are the ones that are the biggest ones. And here's some examples of anthropogenic sources. For like carbon monoxide, the biggest one is our cars. Nitrogen oxides, our cars and buses. Sulfur dioxide is caused by burning coal. So when we make electricity from coal, we're going to make sulfur dioxide. Particulate matters are from road dust. So if you look at these four things, three of them are because of cars and buses and trucks and things like that. Photochemical smog is smog that happens because of photo means sun. Sun plus chemicals make smog. So you can have NO2 in the atmosphere, and it's going to hook up with the sun and turn into ozone. So that's one way that we produce ozone at ground level, which, remember, ground level ozone is bad. So if you have NO2s from any burning source, you're going to make NO2. And then when the sunlight hits it, it's going to react with oxygen, and then you're going to be able to make ozone. What else? Okay, so also if you have nitrogen oxide from your burning, and you also have VOCs, you're going to make ozone plus photochemical smog, and that's the kind of smog that you see, on a really hazy day in the summer. You see it mostly in the summer, and you try to look at Mount Diablo and you can't see it. That's photochemical smog. In San Francisco, the way that the geography is around San Francisco is it's kind of a bowl shape around the city, and this is really true in Los Angeles Basin. They have a bowl-shaped kind of geography. They have the wind coming in from the ocean, and then it's in this little pocket there, and then the mountains are kind of keeping it in there. So because of the way the geography is and the winds that are coming through there, these places have thermal inversions. And what happens is a warm layer traps smog close to the ground and accumulates it, and it's not good. So here's normal conditions. You got the sun is hitting the earth, it's making it warm, and then the warm air is going up, and then as it goes up, it cools off. It gets cooler and cooler. This is natural. This is the way normal things are. But in this little cave-like situation here, this little basin, at night, you can get a thermal inversion. So what happens is you're going to have cool air here, you're going to have warmer air here, and then you're going to have cooler air here, and this warm layer is trapping all the chemicals inside here, all the photochemical smog, and it's not good. So that's called thermal inversion. And you can look at this little chart here. As you go up in altitude, at the lowest altitude it's like middle temperature. Then when you go up to this place right here, it's higher temperature, and then when you get up here, it's cooler. So this is called a thermal inversion. So try to remember this. All you really should remember is this thermal layer, this warm layer is our thermal layer, and it's keeping cool air that has pollution close to the ground, and that's not good. Acid deposition, you've heard of acid rain, I'm sure. So what happens is you're going to have burning from power plants, and from that's where the most of it's going to come, and from cars are going to make this NOx, which is nitrogen, like NO and NO2 and NO3 and stuff like that. It's going to make these guys, and it's going to make SO2 from burning things and other processes, chemical processes and things like that. Anyway, these come up in the air, they get swept all over the place, and when they do a chemical reaction with water in rain, they make sulfuric acid and nitric acid, and then that falls to the earth. So that's why a lot of the Greek and Roman temples and things like that are being decayed because of acid rain. It takes a while, but it's going to happen. It's also not good for all this beautiful land down here with all these beautiful plants. So plants can't deal with really acid rain, and obviously the streams are going to change their pH. So fish are really sensitive to pH. So you can have maybe a change of 0.1 or 0.2 on the pH scale, and they're not going to survive. And salamanders are really sensitive to it. So if you change the pH too much, they're not even going to be able to live. When you change them a little bit, they might be able to survive and reproduce a little bit, but they might have trouble. And then if it gets way too out of their range, then they're going to die. So all the animals that depend on water bases, creek salamanders, fish salamanders, turtles, things like that, they're really sensitive to pH changes. So here's the definition of what I just said. So acid deposition occurs when nitrogen oxide and sulfur oxides are released, and then they pick up rain and they turn into secondary pollutants, which are nitric acid, sulfuric acid. So these are the primary pollutants. These are the secondary. And then when they hit other chemicals, they turn into nitrate and sulfate, and that's bad for the land and the creeks and rivers and stuff like that. So as soon as they hit the lake and the river, they're going to change the pH, and it's going to decrease the species diversity, because there's only going to be those animals that can survive those changes in pH, and the other ones are going to die off. The other weird thing about acid deposition is as soon as you change the pH of water, metals can become more, they can be released from soils and released into surface waters. And this is bad for all plants and animals, but animals especially are sensitive to having metals in the water. And like I said, they can damage buildings. So ways to do this, we can remove sulfur using a fluidized bed, which is a special way of adding. I know you've probably seen drywall, which is the stuff that makes our walls. This like hard hard board that you use to make walls, and that you can make by doing this. You're going to put sulfur dioxide, and you're gonna pass it near this chemical, and it's going to turn into the drywall boards that we have in our home. So that's one way of getting rid of this and actually making a product, which is good. You guys all have catalytic converters on your cars, which are getting rid of the NOx's, the nitrous oxide, the nitrogen dioxide, nitrogen trioxide, things like that. The scrubbers that I showed you on that scrubber picture. Filters you can also use too, because they can get rid of particulates. So they have just like a big giant filter made out of cloth, and then they just pass the exhaust gases through there, and then it picks up all the little particulates. And then you can also add electricity to the particulates, make them have a negative charge, and then you can use a magnet to get rid of them. So that's electrostatic precipitators. So it just depends on what the chemical process is that you're doing. If you're making metal or if you're making paints, which one is going to work best for your process. So here is an example of the bag house one, where they put clean air here, and then they have a filter. They have they're just called a bag, and the gas goes in and it traps all the little particles on the inside of the bag. It's really kind of like a vacuum cleaner. I just thought about that. I never thought about that before, but it's holding on to stuff just like a vacuum cleaner. And this is the electrostatic precipitator one. So you have dirty air in here, you have a negative electrode, you make the dirty air particles negative, and then you have a positive part of the magnet here, and it's going to hold on to all those little negative particles, and then the clean air is going to come out. So that's a cool way to do it too. These particles have to be really dry though to use this to work it well. So that's for really dry gases. And this is the one I was telling you about, the mist that comes, the bad air comes in, the water drops on top of it like rain, and then the particles, the stuff you don't want, is going to go down here, and the clean air is going to come out there. That's a good way to do it too. That works really good for particles, like if you have like that PM 2.5 I was talking to you about, the particulates. Okay, stratospheric ozone is the good stuff. We want ozone in the stratosphere because, and it's way up there above the Earth. It's holding on to, it's in a layer, and you've probably heard about the ozone layer decreasing. It happens over the poles that we have less ozone. Ozone is super important for us because it absorbs UV radiation. So without it, at the beginning of Earth's time, we didn't have the ozone layer, and all of the animals had to live in the ocean because the water would absorb the UV radiation from the sun. And then after a while, plants came around, and they were able to help make us the ozone layer. So ozone, we wouldn't be able to live on the planet without having ozone, because it's going to keep plants from being able to photosynthesize. It's going to keep us, kill us, because it's going to, the UV rays are super energetic, and they'll either outright kill us or give us cancer, change our DNA. So ozone, we couldn't live without it, so we better take care of it. So this is the natural way that ozone's formed. You have UVC is radiation from the sun. It breaks down an O2 molecule that plants make. So here's the UVC and the oxygen from plants, and it turns into two oxygens that are not bonded together anymore. And then you're going to have another oxygen come along, and it's going to bond to these guys and take the O2 plus an unbonded O and make O3. That's ozone. That's what we want. This happens all the time, and it's a natural process, and we can live without it. And then this direction happens all the time, and then the opposite direction happens too. We have ozone is broken down by the UVB and UVC rays from the sun, and forms back to O2 and O. So this is like a recycling project, because this right here then goes back up to the top right here and forms ozone again. So it's going back and forth all the time, and the things that are making it happen are the UVC rays and the UVB rays. So we need this. Ozone is awesome. It forms and it breaks down all the time, and that's natural. Of course, we get in on the act and we change it up. So anthropogenic means caused by man, and we add things to the atmosphere that are breaking things down. So some chemicals will break down ozone, and we don't want to do that. The major thing that does that is anything that has a has a chlorine in it. So chlorofluorocarbons, CFCs for short, are things that are in our refrigerators. They are the refrigerant in your car and your refrigerator that make things cold. So we like that, but if we let them escape into the atmosphere, then they screw up the ozone layer. So CFCs are released where we live on, the surface of the Earth, and they are so light that they can just go way up into the stratosphere. So it takes a while, but they get up there. The UV radiation that's up there has enough energy to break the bond connecting chlorine to the CFC. So then you just have one chlorine out there, and it's going to be able to break apart ozone molecules. So here's what happens when you add chlorine from that CFC stuff. So you got ozone plus chlorine. It breaks it down to make ClO and oxygen. Then that ClO adds to a free oxygen that's up there, like we already said, there's free oxygens up there. And then it makes chlorine plus O2. So you're going to break O3 all the way down to O2 plus a chlorine. And guess what? That chlorine's free again, and it jumps over here and starts the whole process again. So one chlorine atom can break down 1,000 ozone molecules. So it's really, really powerful. It's a catalyst, and it breaks down stuff. So we're not sure how much CFCs are up in the atmosphere, and they are still drifting up. So it could be another 100 years before we know the full extent of how much CFCs are in the stratosphere and how much it's going to break down the ozone. So it's a bad deal right now. Luckily, they think, this is a bad thing. Our ozone's decreased by 10%. It's mostly at the poles. And because this is happening, we have more UVB radiation that reaches the surface of the Earth. Mostly we think about that as how it's going to affect humans, which will give us more cancer and more genetic defects. But it's also going to affect how much plants can photosynthesize. So if you have too much UVB, it's going to burn the plants as well. So it's going to reduce our productivity of plants and crops for us to eat. And it's also going to mess with animals, like for same thing, cancer, genetic variation. So it's a bad thing. And we don't know how long or how much this is going to change, how long this is going to change, and by how much it's going to change, because the CFCs are slowly drifting up like a helium balloon. We let go on the surface of the Earth. It takes a long time to go way up into the stratosphere. So we've let go a lot of these CFCs, and we don't know what's going to happen. So it's a big question mark that you guys are going to deal with, because I'll be dead in the future. Now we also need to talk about indoor air pollutants. So there's a lot of stuff that we do in our house that gives us pollution. So when I went down to Guatemala, the air was full of wood smoke, and also in the home. So lots of developing countries, they're going to use all this different kind of stuff to burn, and all the people inside the homes are going to get exposed to that. So a lot of particulates in their lungs and carbon monoxide, so they're not feeling so great. In the old days, we used asbestos for insulation, and people's homes still have asbestos in it, and that's it. Can go into your lungs and stick in your lungs and give you can kill you if you have too much in there. Carbon monoxide's from improper heaters burning in homes, so people die every year because they don't know that that their heater's not burning properly, and they get poisoned by carbon monoxide. Radon is a gas that comes from the radioactive decay of soil and rocks underneath homes. So people, especially who live in the northern United States, and also people who have basements, this gas can accumulate in their basements, and that can be bad for them. And then we use a lot of volatile organic compounds in our daily lives. For example, hairsprays and hair stuff and paints and things like that. And new homes have a lot of VOCs in them, and that could be harmful to people. So that's all the things you should know about indoor air pollutants. And that's it for this lecture. I hope to talk to you guys soon. Have a great day.